Welcome. Our topic today is gypsum, and you might very well be wondering why gypsum. Gypsum is an abundant, naturally occurring mineral. It is used in various forms for construction purposes to enclose and finish out the interior spaces of our building projects, from our tallest skyscrapers to our tiniest homes. In its natural state, gypsum is known as alabaster. Its unique characteristics have made it a material of choice for many kinds of users over time, from artists for sculpture to lighting designers as the decorative feature of lighting fixtures. Here's a sample of gypsum in its powdered form. We're going to mix that with water in the right proportion for applications on the job. The capacity of gypsum to contain a large amount of bound water is an instance of a material's intrinsic characteristics, as we mentioned in the last module, possessing unique attributes which make it an appropriate material choice to fulfill the needs of a particular construction task. In the case of gypsum, the capacity to hydrate and dehydrate, that means absorb water and shed water, is gypsum's unique attribute. When gypsum is exposed to fire, the bound water is released as steam. This provides a fire barrier until the water is completely eliminated. After the water is exhausted, the gypsum residue remaining continues to act as an insulating barrier to flames. This is what makes gypsum an appropriate material choice for partitions. In being the partition, the gypsum is also there as fire protection of the framing within those partitions. Without this protection, structural materials might begin to fail quickly during fire incidents. We will be discussing this idea in a future module on fire safety. Most of us have had first-hand experience with gypsum when as children we mixed it with water and torn up pieces of newspaper to create an art object. The caverns and tunnels under Paris containing gypsum gave the material its more common name, plaster of Paris. As a substrate, gypsum provides not much more than a support for the finish-facing material, be it paint, wall covering, paneling, or the like. Gypsum is available as boards in various thicknesses, sizes, surface finishes, and formulations specifically designed for particular uses. Here we see gypsum in the board form, rectilinear, solid, 4x8 boards, though they do come in different sizes. Because as gypsum boards come in thin, flat, wide, and long, the board form of gypsum is most conducive to creating rectilinear spaces and geometrical enclosures, not curving, sinuous, or abstract shapes, though slight curves or bends are possible. Gypsum plaster is the superior substrate for accepting finished materials such as paint. The surface smoothness of the substrate might display through the finished material. I'll explain this thought in more detail in a little while. Gypsum plaster is the most labor-intensive and costly type of gypsum construction system. Because gypsum plaster is applied in a wet slurry formulation, as you can see here, which dries hard, it is well suited for sinuous and flowing planes of superior surface quality. As you can see here, these are not geometric shapes, these are abstract shapes, which can be molded using a wet source. Plaster veneer is an alternative to and combination of the full plaster system we just saw and the gypsum wallboard system we've already talked about. Many of the labor and installation expenses of a full plaster system are eliminated, and while the resulting substrate is not as good as that of a full plaster system, it is still superior to a gypsum wallboard finish. Materials comprised of gypsum provide many advantages for use. Gypsum is hard and durable. That means gypsum construction takes abuse pretty well. It is used to create surgical and orthopedic casts. Gypsum is fire resistant. We have already hinted at gypsum's effectiveness as a component in a fire-resistant or fire-retardant assembly. Gypsum is sound resistant. For good or for bad, the hardness of gypsum in place supports the transmission of sound waves within and around a space. In an intimate restaurant, this may not be so welcome, while in an event space, this might be helpful for reaching the back row. Fast installation, that is, gypsum is manageable by a single installer, doing several installation steps simultaneously, or at most, just a few installers for larger pieces. And gypsum is easy to repair. Small damage can be easily and quickly repaired with no particular skill set needed. Gypsum is lightweight, again manageable by a single installer or at most just a few installers for larger pieces. Gypsum is inexpensive, especially attractive to tight budgets while providing durability and a more than acceptable appearance. Finally, gypsum is an excellent substrate. Its worth as a substrate depends upon the particular performance expected. A material may have those advantages, and it must certainly then well have its disadvantages. So therefore, we can say that gypsum is not resistant to water. It supports mold and mildew growth. The surface paper of the gypsum wallboard. You can see here, there's paper on both sides of the gypsum. The surface paper of gypsum wallboard is available in a variety of types, the choice of which is dependent upon performance expectations. There are paper finishes which will inhibit the growth of mold and mildew in wet applications. There are paper finishes which will hold gypsum residue in place for increased fire resistance protection. There are paper finishes as well for water repellents, and there are others. Not structural, gypsum is hard and durable, which is not to say that gypsum is a structural material. It is not. However, gypsum construction systems do need a supporting framework on which to be mounted. That's what we're going to talk about when we speak about metal studs and wood studs. Gypsum reflects sound. We said the hard surface of gypsum promotes sound reflection off of it. This can be an unpleasant consequence which needs to be addressed, or a welcomed consequence which might be exploited. Gypsum lacks intrinsic character. It contributes not more than a surface on which to apply a decorative finish. There are some benefits to our environment which the use of gypsum as a building component provides. One benefit is that it has little negative impact upon our environment. Gypsum is not a contaminant which harms us or our children. Hopefully, it will not be discovered at a later date to harm our children's children. We are all familiar that there have been useful materials in the recent past which once thought not harmful have now been proven to be toxic and carcinogenic, such as lead and asbestos. Gypsum is not poisonous and is used as a primary ingredient in toothpaste. Gypsum is recyclable. You typically find on a construction site where there's demolition going on that there's a pile for used wood, scrap wood, there's a pile for scrap metal, and there's a pile for gypsum. Here's a drywall pile being ready for transport for recycling to be used again as gypsum board. I will say that unlike the other materials, metal is a material that you recycle and you can actually get paid for that metal. It's that valuable. The facing paper, which I just showed you, is used on the gypsum surfaces again and used for other recycled paper stock, such as newspapers. There is no supply shortage of gypsum currently and none expected going forward. I proffered earlier that gypsum lacks intrinsic character, that it is plain vanilla, bland, flat, a background material, a wallflower, just for dressing up. But looking at this slide, and this slide, one could actually argue that its dullness is a good thing, right? It is a background that actually can use the planes created from the material as demonstrative of forms and spaces into which our other, perhaps more impactful design features are brought to prominence. Interior finishes encompass all materials and surfaces that can be seen or touched. The choice of materials and the methods of construction should be based on the function of the space, the anticipated volume of traffic, acoustical effects, fire resistance ratings, aesthetic appearance, and of course, many more things. The prevalent application of gypsum is as boards, so I'm calling this our first method. Gypsum board is less expensive, requires less labor, less skilled labor, and less time than any other appropriate alternative substrate, were there in fact a comparable substrate on the market. In different areas of the United States, the terms drywall, gypsum board, gypsum wall board, plasterboard, and sheetrock are synonymous one with the other. In fact, sheetrock is actually the trademark name of one company's gypsum wallboard product. We can see from this slide that GWB gypsum wallboard comes in different face paper colors. Each color denotes a particular characteristic which makes that particular sheet suitable for an application. So here we have green. This is specified as moisture resistant board, substituted today in the most part by something called cementitious backer board, which is a cement type board used now more prevalently in wet or moist locations. The white is just a standard piece of gypsum board. We'll be talking about some of the particularities of the other colors as well going forward. This is a sample off the job of cementitious backer unit, CBU. You can see it's concrete or lightweight concrete with fiber mesh to hold it together. It's much more impervious to water and moisture than even the best moisture resistant gypsum wallboard. So it's used in areas primarily where you have showers or bathrooms and are going to be applying tile to the face. Also called Durarock or Wonderboard. Sheets are normally 4 feet wide and 8 feet long, but they are available commonly in lengths up to 16 feet. Gypsum wallboard sheets are available in increments from 1/4 of an inch up to 1 inch, with 1/2 inch, 5/8 inch, and 3/4 inch being the most popularly specified. The thickness of the GWB that you will specify for your projects will depend upon the task that it's meant to serve, whether it be for fire rating or sound attenuation, or just using a thin sheet to cover some irregularities on a former partition. The larger the sheets, the fewer joints there will be once installed, and the reverse is also true. The smaller the sheets, the more joints there will be once installed. Each exposed joint between wallboard pieces will need to be concealed and finished. So ask yourself this: is it more efficient, productive, and result in higher quality to use larger boards or smaller boards? Large boards require 2 or 3 workers to install, but will have fewer joints for finishing, which in turn will result in a more perfect surface finish upon which to apply the paint. Smaller boards require 1 worker to install, but will have many more joints for finishing, which in turn will most likely result in a larger number of surface imperfections over which to apply the paint. Think about this conundrum while we discuss the actual methodology for gypsum wallboard installation. The installer, referred to on the job as the sheet rocker or rocker, uses screws, not nails, when installing the gypsum wallboard. It is the threaded shaft which makes the difference. Let me show you an example of some sheetrock screws. Hopefully you can see that these are threaded. They create more friction to hold the material better to the wall structure behind the gypsum. Nails, on the other hand, are smooth shafts without that added threaded resistance, so they could pull out much quicker and more easily, or the screw is less likely to become loose and back its way out than a nail with a smooth shank. Here you can see a nail pop. These are screw holes, somewhat recessed, that will then be covered with a material for finishing. So specify screws, and if you see nails being installed, stop the job and settle the issue. That the client's best interest is your responsibility. The long edges of wallboard are typically, though not exclusively, supply tapered with a beveled edge. The taper width is about 2 inches. You can see in this slide, hopefully you can possibly see in these examples, that when you butt up 2 pieces of gypsum wallboard, there's an area adjoining the joint that is somewhat depressed. Into that area will be the filler or the spackle and a piece of tape that will close that off and make it smooth between the adjacent boards. This tapering at the long edges allows for the tape and joint treatment to be applied, resulting in a finish that should be flat, smooth, and monolithic. I emphasize should because a good taper spackler can make even a poorly done installation job look fine. Always insist upon the best taper spackler for this stage of your construction project. When I speak about spackle, I'm referring to this muddy consistent material that goes on soft and dries hard. It's available in a variety of formulations for particular outcomes. The color of the lid container of the spackle, also known on the job as mud or compound, is referred to as a bucket and represents to the taper the particular applicability of that spackle to performing a particular task. Drying times, which has a green lid. A lightweight spackle for finish coating has a blue lid, while quick drying spackles have, I believe, a light blue lid amongst other types. The tape part of tape and spackle comes only in either fiberglass mesh form or paper form. This is a sample of the mesh form. It's got a slight adhesive on one side and so can be self-supporting for a short while. This mesh type is reserved primarily for small repairs because of its superior stability. Paper tape is the most common for all other uses. Both come in rolls, as you see. Paper tape has a crease down its center, which can be folded to easily place the tape into a corner. There's a crease in the center. You could just fold it like that and have it ready to put into a 90-degree corner. A first application of compound, or as I said, mud or spackle, is typically applied to all joints using a wide 5-inch spackle knife. The knife will cover the 2-inch spacing of the feathered edge of each adjoining board. The tape is then placed to cover the joint and is pressed into the mud. Another layer of compound is applied, feathering the outer edges. After drying, the compound is sanded and a third coat is applied, with the feathering extending beyond the previous coats. All screw holes are also filled with joint compound and sanded smooth as well. Sanding should be limited only to the area that has been coated with compound, because sanding the paper layer will result in a roughness that may be visible through a paint finish. The appearance of these rough surfaces blemished by sanding, contrast alongside the normal paper finish surface, is what many observers find objectionable once the paint is dried. And then it's too late. Due to the vulnerability of outside corners to damage by human activity, there is a reinforcement available to install which protects and delineates a crisp 90-degree edge at the meeting of 2 pieces of wallboard. This accessory is called a corner bead. Here's a sample of a corner bead. I can also show you on this sample of a partition, metal stud partition, the introduction of the corner bead. Corner beads are fabricated to accept compound into a dimple which when properly feathered and spackled will align to the planes of the adjacent wallboard surfaces. Perhaps you can see a slight dimple right along that line that will accept a little more thickness of spackle, which can be then feathered down to the adjacent edge. Corner beads come in 8-foot and 10-foot lengths and are installed end-to-end for long runs. Other accessories, such as J beads, named because of their similarity to the letter J, exist for common drywall to drywall intersections, or where drywall intersects with a similar material. Here's an example of a white J bead. It's finishing off this portion of wallboard in a nice, neat way because perhaps it's adjoining a dissimilar material and there's really no way to finish the edges. So you would have the gypsum board with the J-bead up against the piece of wood, and it looks good. So here's a view of what we call paint-ready gypsum wallboard partition. The next step here is just to paint the wall. The spackler has come in, done his spackling and sanded the job to perfection, and the painter simply needs to come in and start coating with the primer as a base coat for his paint. The painter first needs to accept the job from the sheetrock installer and from the spackler, because he then takes responsibility for the quality of the finished coat that he's applying to the substrate. So sometimes the painter will come in and find things that he doesn't like and either fix them himself to his satisfaction, or he may ask the client to have the sheetrock or taper come back and finish the job a little better for his own standards. So here we can see different types of application of spackle. Here someone just came through and very efficiently, where the boards join, swiped with his spackle knife, a quick smooth stroke, and does the same with where the screw holes are, and he never lifts his tape very far off the board. It's a very smooth operation. This gentleman did, I'm sure, an equally good job, but you can see that he treated each hole independently. Probably took him a little more time. Perhaps wasn't quite as skilled as the other gentleman over here. So now let's continue on to what I'm calling our second method. Our second method is a gypsum system called plastering. The plastering system dates back to ancient Egypt and Greece, when intertwined reeds were used as backing to accept the wet plaster. As I said, gypsum wallboard is constrained to planar shapes for the most part. So a case could be made that without the constraints of the board form, that wet plaster applied properly in a liquid state and allowed to cure into a dry state can outperform the wallboard form of a gypsum. But does the superior performance of a wet plaster application warrant the associated higher material and labor costs? Is the effort worth the expense? This is a discussion between designer and client. As designer, you need to understand the issue in order to raise the question. For many high-end residential, corporate, and governmental projects, quality, longevity, and facility upkeep outweigh immediate cost consideration. On smaller projects, maybe cost considerations will dictate final choices. I said that the Egyptians used intertwined reeds as a backing material for their early form of plaster. The backing material which forms the frame upon which the plaster will dry is called lath. Half-timbered homes of the English Tudor style use lath of saplings and reeds. So technology advanced from reeds to wood, and from wood to metal mesh, and from metal mesh to non-rusting metal mesh. The distinction between rusting and non-rusting is important because plaster, as we discussed earlier, will rehydrate, meaning that it is porous and will accept water when exposed to it. If the plaster is subjected to humidity or moisture, the metal lath on which the plaster rests can rust and the plaster loosen and fall away. I have here a sample of plaster on lath, and that lath was not galvanized or made rust resistant, and that on this piece of plaster corroded and fell to the ground, and that's how it ended up in my hands. Today we prefer to use the galvanized metal lath. Here's two pieces. We call this expanded metal lath, and it's malleable and galvanized. Malleable meaning bendable, just like a paper clip. Galvanizing protects the decomposition of iron and steel against corrosion and the eventual failure of the material to function as intended and needed. The galvanizing process is a process whereby zinc is applied to the surface of the material. The full plaster method is the process whereby gypsum material is strategically layered, one layer upon another, each layer accomplishing a particular prerequisite of the layer to follow, until a cohesive whole assembly is formed. This slide describes that layering process. Upon a framework of lath, a scratch coat is troweled on, some plaster is squeezed through the mesh to form a mechanical bond. a key. The coat is left rough to provide tooth. Hope you can see here the lath, in this case wood, and the first coat of plaster called the scratch coat is squeezed into that lath and allowed to dry. The brown coat is applied next and gives bulk to the wall. It is also left rough to provide tooth. The finish coat is applied thinly and smoothly to provide as nearly a perfect substrate as is achievable. Take a moment to look closely at the vertical wall section detail in this slide. Find the grounds. Then imagine holding a long straight edge flush against two opposing grounds, say one at the floor and the other at the ceiling. Imagine now pulling that straight edge parallel to the wall surface, maintaining contact with the two grounds. You can understand that the wet plaster is made smooth in this way, leveling high areas and using the excess to fill in low areas. Frescoes were painted on wet plaster, which absorbed the pigment so it dried as an integral part of the plaster. Since the artist could only paint an area where the plaster was still wet, the amount of progress the artist could make was painstakingly slow. Now let's continue on to what I'm calling our third method. A veneer is a thin layer of a material applied to a substrate for dimensional stability. Veneer plaster over gypsum lath refers to a gypsum plaster board which predates but acts similar to present-day gypsum wallboard as a substrate. Gypsum lath is a panel having a core of dense hardened gypsum plaster. It is faced with fibrous, absorbent paper to which plaster adheres. Gypsum lath was originally made in sheets 16 inches by 48 inches, but currently is available 2 feet by 8 feet. It has a pattern of holes per sheet to accept the plaster key. Gypsum plaster is applied over the gypsum lath and a monolithic base coat, followed by a thin finish coat, creating a complete plaster cladding. Joints, angles, and fasteners do not need to be taped or spackled. Veneer plaster over gypsum wallboard starts first with a factory finished gypsum powder ready to be mixed with water on the job site. The mix is applied as a very thin 1 or 2 coat finish over types of gypsum wallboard specially formulated with face paper having a surface which is highly absorptive. In the case of veneer plaster based gypsum board, the joints, angles, and fasteners do first need to be taped and spackled. A veneer plaster system can offer economy and efficiency with a minimum of sacrifice to substrate surface smoothness. As designers, we need to understand what level of substrate satisfaction does the client expect for their budgetary constraints. It is essential to understand what the surface finish will be. Does the client expect, for instance, to be using a high-gloss paint? On one end of the spectrum are high-gloss paints which show all the surface substrate imperfections, and at the other end of the spectrum are flat paints which will show imperfections the least. To recap, there are 3 gypsum wall systems: gypsum wallboard, GWB, prefabricated panels, often called sheetrock or drywall. Plaster, a dry plaster powder mixed with water and applied wet in the field. And 3, veneer plaster, a combination of thin plaster finish coat over gypsum lath or wallboard. Now some other relevant information to gypsum. Buildings are constantly moving. Buildings are constantly moving because of changes in temperature and humidity, because of wind, because of vibrations caused by equipment and the vibration and movement of people. The movement is very slight but can cause groaning structures. We've all been in guest houses or strange places where when we're sleeping we think we hear noises. Well, we do hear noises, and those probably are the noises of the building moving. Those movements, besides being manifest in the sounds that we hear, are often visible in different cracking areas. We often have cracking where the ceilings and the walls meet. Well, crown moldings were invented to cover the areas of this vulnerability. I have some samples of crown molding. I hope you all know what that is. It refers to a material that's going to cover the intersection of the wall meeting the ceiling. Crown moldings have the added benefit as contributing to the overall interest of a room by creating dimensionality and shadow lines. Crown moldings are available in a variety of sizes, profiles, costs, and material composition. The terms cornice and crown molding are often used interchangeably. I've heard it said that a cornice height should be equal to 1/10 of the floor to ceiling height of the room. Crown moldings are available in a variety of sizes, profiles, costs, and material composition. Here I have a sample of a wood molding. You can see it's made up of several different sections or profiles to be mixed and matched at your pleasure, whatever profile you could invent and have made. You can create your own cornice. We also have the older style of cornice, cast in a mold. This is plaster, reinforced in the back with some meshing and some wood. And nowadays we also have a type of crown molding made out of fry pan. It's kind of a styrofoam material, and you can create and assemble pieces of all sizes, and it doesn't become heavy. You can actually lift it right up into place, probably with 1 or 2 people, and it's not attached with a mechanical fastener, although it could be. It's generally glued. The terms cornice and crown molding are often used interchangeably. I've heard it said that a cornice height should be equal to 1/10 of the floor to ceiling height of the room. In the absence of crown moldings, the intersection of wall and ceiling is finished by a typical corner application of paper tape and spackle. Here you can see the tape going in, turned at the crease at a 90 degree. Here's an example of a detail showing a vertical section through a typical wood frame wall with gypsum board facing where the wall and ceiling meet. Floor and wall intersection is another place requiring additional detailing by the designer. This area is in constant need of maintenance because of its proximity to our daily activities. It is an area prone to abuse and needs to be protected and fortified. The covering used is referred to as base or wall base, as it covers the base of the wall. The choice of wall base material depends upon expected performance and longevity, flammability considerations, and sometimes just plain personal taste. Here's a beautiful piece of floor base. More expensive than the typical clam shell base, which is the most common. And you would be given this by your contractor for your job if you haven't specified what you really wanted. And of course, it'll be an upgrade and an added expense to your client. So we always specify to the hilt everything that we know the client wants and the type and style and cost level of what it is they wish. A piece of solid wood as wood base is optimal, as opposed to wood composite materials which may be absorptive and expand or otherwise react poorly. Here we see a solid piece of wood. This too is a solid piece of wood. Perhaps you can see this is not a solid piece of wood. There's a joint intersection here, and that's called finger joint. The cost of wood base can be a budgetary concern, so it's important to know what finish the base is expected to receive, as finger joint is much less expensive than clear. Here you can clearly see the finger jointing. This is where you would use that less expensive wood because you knew you were going to be painting it. You wouldn't want to use that if you knew you were going to be staining or have a clear finish. You'd want a piece of solid wood that was clear. While the particular profile and height of the base is of budgetary concern, generally base is chosen for the aesthetic contribution to the overall room design. After all, some simple base will need to be used, so there is already a minimum expense involved. How much more will a more appealing base cost? The term base can refer to both resilient base and wood base. Resilient base is pliable, easily conforms to most curves, generally easy to install, and relatively inexpensive. Rubber base is more expensive than vinyl base. Resilient base is available in a very wide range of color choices to match most any wall or floor finish color. Here's a small sample of wall base. You see it's flexible. The color choices are many. The application is by adhesive to the back of the base and pressed against the wall. Some base has a strip of adhesive tape on the back installed at the factory. This adhesive tape is not as strong as the adhesive, also referred to as mastic, available for field application. Resilient base is available in two profiles: straight for use with carpet. Here you can see straight base with the carpet either butting up against it or the base sitting on top of it, and cove for use with other types of flooring. This is the cove base. There's a little flange projecting out. We call that cove or sanitary base. It's given that name because it's much easier to clean that little cove, the floor intersection, and keep it sanitary than it is to clean the previous straight base, which gives you a 90-degree angle where dirt could hide out. In summary, the surface of the substrate created by the different types of gypsum application methods vary. Which is the right application for your client's project? Thank you.